Welcome, differentiation or differential calculus grade 12. In this particular section, we are discussing the first principles, differentiating using the first principles, grade 12 mathematics paper 1. Thank you very much for watching this video. Please subscribe and encourage all your friends and brothers and sisters to do the same thing, so that we may be able to reach as many people as possible who may need help in maths. So yeah, there are a few examples that have been put up here explaining how to differentiate using first principles. Let's get on with it and see how we can advise each other on what to do. Differentiation, first principles, grade 12. Differentiation from first principles. Let's quickly have a look at how to differentiate using first principles. Now, in this particular section, we're going to discuss the method of splitting your calculation into three sections. Number one, determine the value of x plus h. Number two, determine the value of f of x plus h minus f of x. And number three, substitute into the formula and simplify. Now, these are the three steps. Determine the value of f of x plus h. Then determine the value of f of x plus h minus f of x, and substitute into the first principles formula, and then simplify your answer. Let's have a look now at the practicality of these three steps. This is our formula that we are going to apply. In this formula, in the numerator of this expression, we have f of x plus h, and that is the first calculation we are doing in number one. Then the whole numerator is f of x plus h minus f of x. That is the second calculation we are doing into number two. Then the third one is substituting. So let's have a look at how this works. Number one, I want to find the value of f of x plus h. What it means is that in place of x, remove this x and substitute with x plus h, such that x squared becomes x plus h, then squared. After that, you simplify. This is definitely the FOIL method. So in between here, you can have x plus h and then factor of x plus h. And after that, you go ahead and remove the brackets by the FOIL method. We are repeating x plus h, factor of x plus h, because that is the meaning of these two here. It means we are going to expand those brackets using the FOIL method. Now, if you do that, this is our answer. X times x, we get x squared. X times h, we get xh. H times h, we get another xh. That's end up giving us 2xh. Then h times h, we get h squared. We have done the first calculation. Calculate the value of f of x plus h. It means in your expression, replace x with x plus h and simplify. Number two, determine the value of f of x plus h minus f of x. What does that mean? What we just calculated in step 1 is f of x plus h. From that answer, we're going to subtract f of x. So if you look at this expression, this whole part here up to here, this is my f of x plus h. This is my f of x plus h. Then if you look at the next one, which is the last part of that expression, you will see that this last one here is the value of f of x. So this is the first part is f of x plus h, and the second one is f of x. Then I simplify this expression to get a simplified form. It's going to be 2xh plus h squared, because this x squared minus that x squared will give me 0. Then the third step, you substitute into the formula. The formula for first principles says that the f prime of x is equal to the limit of f of x plus h minus f of x over h as h approaches 0. So in our formula, this whole numerator here, this is what we have calculated in step number 2. So what we're going to simply do is to take out this entire numerator and substitute it with our answer to the previous calculation. Now our expression will look like this. This is the limit of 2xh plus h squared over h as h approaches 0. Then to complete your answer, we use factorization. Factor out h from the numerator. It will give you h factor of 2x plus h, so that the h that you have factored out and the denominator are divided. Then the remaining h approaches 0. Therefore, substitute 0 into h, and that gives the answer to that question. So this remaining h becomes 0, and once it becomes 0, we have reached the limit for this expression. Our answer is going to be 2x. We have differentiated this expression using the first principles formula by following 3 steps. Once again, differentiation from first principles. Let's have a look at how to differentiate from first principles. Now, in this case, we are breaking down our calculations into 3. The first one is determine f of x plus h. The second one, determine f of x plus h minus f of x. And the third one, you substitute into the formula and you simplify. This is helpful for those learners who may not be able to do everything at once. You can break down your calculations into the 3 mentioned steps. Now, we need to be clear about what does it mean to say determine f of x plus h. It simply means in f of x, this x here, you remove that x, and in that position, you substitute x with x plus h, so that 3x squared minus 4 now becomes 3x plus h squared minus 4. This is what we mean by the first step. Calculate the value of f of x plus h. It simply means in your f of x, you are going to remove x and replace it with x plus h. So once we do that, we now simplify in the normal way, removing brackets and simplifying expressions. X plus h squared needs the FOIL method to be simplified. This square here means the bracket is repeated. So you are going to repeat the bracket and then FOIL out the brackets and simplify. There we are. X times x gives us x squared. X times h gives us xh. This h times x also gives us xh. And h times h gives us h squared. In simplified form, it's x squared plus 2xh plus h squared. After doing this multiplication, then we multiply by 3 to simplify our answer for f of x to its simplest form. That is step number 1. You calculate the value of f of x plus h. Then the second one, we need to calculate the value of f of x plus h minus f of x. So notice that the f of x plus h, that is what we calculated in the first calculation. This whole expression that we got here is the value of f of x plus h. Then f of x is the original expression given. The f of x is equal to 3x squared minus 4. So that's what we are doing here. So simply put, it means in the expression that we got in our first calculation, we're going to remove the original terms of our expression. So if you simplify, you are going to notice that this 3x squared here minus that 3x squared, that will give us 0. Then this negative here, a negative and a negative makes it positive 4. So the positive 4 that we get and the negative 4 that is here, that one there and that one, they also become 0, such that our answer becomes 6xh plus 3h squared. It is vital for you to do a quick check to find out if your answer is correct or not, by making sure that when you do the second calculation, f of x plus h minus f of x, every term must contain h as a common factor. If that is not the case, it means there are some mistakes in your calculation. Now we go to the third part where we substitute. Our substitution is done in the formula for first principles, which says it is the limit, the derivative is the limit of f of x plus h minus f of x over h as h approaches 0. Notice that the numerator of this expression is what we have calculated in step 2. So we're going to remove the entire numerator and replace it with our answer from the previous calculation. So that means going forward, in place of the numerator, we have 6x plus h plus 3h squared. To complete your answer, use factorization. You factor out h from the numerator so that the h you factor out and the denominator, those two are divided. So now we are left with the limit of 6x plus 3h. The remaining h becomes 0 because h approaches 0. If that becomes 0, then it means in this expression, the remaining value is 6x. Therefore, the limit is 6x. Therefore, the derivative of f of x is equal to 3x squared minus 4 is equal to 6x. That is differentiation using first principles. If you choose to break down your content into smaller calculations, this is one option that may apply. Otherwise, all calculations in this section are basic, and we expect everyone to be able to do them without getting diarrhea because of the maths. Differentiation from first principles, grade 12 mathematics, paper 1, the CAPE syllabus. Let's have a look at how to differentiate from first principles. These are basic mathematics calculations that all of us are supposed to be able to do if we simply pay attention to it. Now, how do we differentiate using the first principles? The formula says that the derivative is equal to the limit of f of x plus h minus f of x over h as h approaches to 0. We are going to do direct substitution into this formula. So our expression will look like this. We need to understand the different parts of this expression so that there is no confusion. The first part of the formula is f of x plus h. That is what I have from here right through until here. If we say to you f of x plus h, what it means is that in f of x, the position, I'm going to call it that way, the value of x in your expression, x is appearing twice in this expression. You remove that x, and in the position of x, you put x plus h. So we are substituting x with x plus h such that 2x, which we have here, becomes 2 factor of x plus h. 5x squared becomes 5 factor of x plus h squared. That is what we are doing. Then from there, we simplify normal in the normal way. x plus h squared is equal to x squared plus 2xh plus h squared after removing the brackets by the FOIL method. Then this 5 has to multiply this product. So use the squaring first. After that, then we multiply by 5 all these terms to complete our expression. So we simplify. Then like terms, please be careful with negative numbers. If you look at the expression, the last terms of my expression, you will notice that there is a negative here. And then we are subtracting two terms. So which means the first one must be negative 2x and the next one must be positive, because negative times negative makes it positive. Now we need to get rid of like terms. Minus 5x squared plus 5x squared, that gives me 0. 2x minus 2x gives me 0. Now I'm left with 2h minus 10xh minus 5h squared over h. I've done my studying already, so I should somehow know where this expression is going. When you reach here, we have to factorize h. And if it happens by any chance that in your expression you don't have a common factor, let's say there is something else 2x here on my numerator, now that will make factorization impossible. It's a sign that my answer is not correct. We should make sure that our numerator, after simplifying, we have h as a common factor throughout, so that we can factor out that h. If you factor out that h, then you are left with 2 minus 10x minus 5h. Now, to complete your answer, the h that remains there becomes 0, because in this expression, h is approaching 0. If you put 0 in place of h, we have reached the limit of this expression, and the limit is going to be 2 minus 10x. Therefore, the derivative of this expression is 2 minus 2x. We have differentiated this expression using the first principles formula. So the expression is a bit long. I must put effort to make sure that I avoid unnecessary mistakes. Otherwise, your calculation is pretty much straightforward. All right, let's have another example on differentiation from first principles, grade 12 mathematics paper 1. These are basic calculations that we expect everyone to be able to do. If you pay attention to it, you will realize it's not as complicated. So we are doing direct substitution into the formula. The formula says the derivative, the f prime of x is equal to the limit of f of x plus h minus f of x. What does the formula mean? The first part of this formula is f of x plus h. It means in your expression, the position for x, you remove that x in the entire expression and replace it with x plus h, such that x squared now becomes x plus h and then squared. 2x now becomes 2 multiplied by x plus h. That is what it means to say f of x plus h. The second part of this expression, this is your original expression as it is. So we now substitute. F of x plus h is x plus h squared minus 2 times x plus h. So this whole part here is what we get after putting x plus h in place of x. Now we simplify this expression. X plus h squared. Please, x plus h squared means the bracket is repeated. So we're going to have x plus h and another x plus h. Then we use the FOIL method to simplify those brackets. Remember that x plus h squared means the bracket is repeated, And then after repeating the brackets, we apply the FOIL method to simplify it. So if we do that, this is what we have. We get x squared plus 2xh plus h squared minus 2x minus 2h, and then minus x squared plus 2x. Please be careful with negative numbers. If you look at my expression, you are going to see, follow through the negative numbers. You are going to see that in this expression, these two here, when I remove those brackets, it's negative 2. Therefore, it must give me negative 2x and negative 2h. Then when I remove the last brackets, there is a negative outside that will give me negative x squared, and the next one, negative times negative, makes it a positive 2x. Now we need to simplify. Simplifying means you are basically adding and subtracting like terms. So x squared minus x squared minus 2x plus 2x, those are the like terms I have. Now my expression is now smaller. At this level, please make sure that every term has h as a common factor, because from here we need to factor out h. If it happens by any chance that at this part of your expression, after adding like terms, h is not a common factor, then it's a sign that your answer is not correct. We must have h as a common factor so that this factorization here becomes possible. After factorizing, the h, which is a common factor, and the outside, the denominator h, they are divided. So you can simply cancel those ones out. Then the remaining h becomes 0 because h approaches 0. So the answer to this question is going to be 2x minus 2. That is the derivative using the first principles. We have differentiated using first principles. If you can just be careful to make sure that you take care of these negative signs and your substitution is done well and the brackets are simplified correctly, there can be no reason to get wrong answers in this. It must be something that we can all do. That is differentiation from first principles, grade 12 mathematics, paper 1. Thank you very much for watching. Thank you very much for subscribing, and thank you for encouraging all your friends and brothers and sisters to do the same thing. Yeah, let's meet again in another video when we discuss more mathematics ideas. Thank you very much. We meet again.